I'm a software engineer at a tech company, and right now I'm based out of London. And what I do is basically I work on the back end of a system which ingests a large amount of data and stores it and exposes it for future use. And uh, before before I get started with, I guess, any Python specific lessons today, I wanted to get like a slightly better understanding of your backgrounds and what you want to achieve from this course. So there's obviously way too many people on the group for us to have a conversation, but like maybe you could write out in the chat like what's one thing you imagine you'd be able to do at the end of the course, or what's one thing you'd like to be able to do at the end of the course. So yeah, I'm looking at the chat, so we'll give everyone a couple of minutes.
Hello, sir. Can you start your video?
Uh, yes, so Zoom is not allowing me to turn on my camera. I'm going to share my screen.
You are not able to start your video, sir. Okay, it's visible.
Yeah, I'm unable to share my camera, and I'm not sure why. Okay.
Okay. Yes, sir. It is visible.
Awesome. And can you all see the window I'm sharing?
Yes, sir.
Okay. All right. So I'm seeing a couple of responses. So yeah. So I see that you haven't done any specific problem solving yet. So let's try to work towards something like that today. So if I understand correctly, in the last couple of lectures, uh, you learned about variables and lists. So let me share this. All right. So I'm going to type out like a very, very obvious block of code. Okay. So yeah, so this block of code is doing something really obvious, which is storing a value in this variable. So we're storing the value 10 in a variable named a, and then we're printing out that variable, and so we see 10, which is inside A. So uh, before we get like way into the features of Python, I wanted to talk a little bit about like uh, programming in general, and something which is common with like most languages, which is how to organize your code and how to actually build something larger with the pieces you have. So so the part I want to focus on is this thing called print. So print is actually a function, which means that when you write print, it goes and runs some other code. And so functions are a way to uh, functions are a way to abstract away the code you have and reuse them and share them with with the rest of your code base and also potentially other people. So let's start off with how exactly you would define a function and use it. So the Python syntax for defining a function uses the def keyword, and then you specify the name of the function, which follows the same rules as variable names, and then you specify what arguments it takes. So I'll skip the arguments part for now, and I'll get to so I'm going to define a function called let's just call it print 10, and this function prints 10. And so when I run this block of code, nothing will actually happen because the only code in this block is defining a function, and we're not actually using that function anywhere. So that's why there's no output for this block of code. So now we have this function called print10 available to us, which we can use anyway. So let's try using that. So calling a function, the way to call a function is to specify its name, which is in this case print10, and then tell it what arguments it takes. And in this case, print10 takes no arguments, and it's supposed to print 10. So that's exactly what happens. So when we write print10 here, what's actually happening is Python is going to look for a variable named print10, and then it finds that print10 was defined here, and inside that function definition, we see what code it's supposed to run after we hit that, and so Python runs that. And so that's, I guess, the simplest way I can think of like defining what a function is. So before I go any further, I am keeping an eye on the chat. So if something's not clear, please just type out in the chat sooner rather than later before it gets even more confusing. All right. So the main purpose of functions is basically organizing your code and giving you tools to compose them and build something larger. So for example, let's now define a new function called new function called print double. And this function takes one argument named a. And so now inside this function definition, we can use this variable a and write code which will operate on that variable. So so what I'm going to do inside this function is to just print whatever argument was given to the function twice. So now we have this function called print double. And so now let's try actually using this function. So yeah, so I'm just typing out print double like we did print 10. And yeah, and we see that there's a syntax error here. And I deliberately triggered this error because I wanted to take a quick tangent into error messages and how to deal with them. So the error messages in Python are usually very helpful. And so whenever you get an error, you should take a moment to actually read it properly, because it pretty much always tells you exactly what mistake you've made. So right now, this expression I wrote down, which is calling the function print double, errored out because print double is missing one required argument, and so which is a. So the way to solve this is to supply it an argument. Okay, yeah, that's a great question. So an argument is what we supply to the function, and so let me show you by example. So right now I'm calling print double with one argument, and that argument is just the string called argument. And so when this function is called, it goes to the definition of that function, and it replaces the the name of the argument we've specified here with whatever the caller of the function decided to provide, which is in this case just argument, and then it operates on that. And this argument can be any type. So for example, let's see what happens if we call print double 2. So we're seeing the error when I called it without an argument, but there is no error when I called it with an argument. So when I call it with an argument, it runs fine. It prints the argument twice. And now let's, when I call print double with an integer, it does the same thing, which is it prints argument plus argument. And in this case, 2 plus 2 is 4. So similarly, this function would also work for a list. So if I call this function with a list, it's going to print that list twice. And and so that's what an argument is. And a function can take more than one argument. So it can actually take any number of arguments. So so let's define a new function which takes more than one argument. And yeah, so let's define a function called I don't know, let's call it print 2 things. And this function, let's have it take two arguments, and I'm going to name those arguments A and B, but they can be, they can be any valid variable name. And let's print both those arguments separately. All right, so now, so now we have a function called print two things, and it's expecting two arguments, and the names of those arguments are A and B. So, so let's try calling it now. So let's call it with a string called argument 1 and an integer called 200. And we're specifying the two arguments and splitting them with a comma. So the way to read this block of code is basically call print two things with two arguments. The first argument is a string called argument 1 and then comma. So that means we move on to the second argument. And the second argument is an integer called 200. And and we can see that this function called print two things now basically just printed out the first argument and then printed out the second argument. And and the same concept like expands to more than two variables. It can take an arbitrary number of arguments. And so now let's see how we can actually use functions to actually wire things together or like build something more complicated. So now let's define a new function called let's define a function called add two things, and let's have them take two arguments named X and Y. And this is very similar to the previous case where we take two arguments and then just print them out. But here let's do something more useful than just printing something out. So let me define all right, so this function actually let's skip this for now. And define something simpler. I'm defining a function called 5, which takes no arguments, and I'll have it return 5, return the integer 5. So what this does is that whenever any piece of code calls this function named 5, it's going to return the integer 5. So So let's try using it. So yeah, here I'm defining a variable called x, and I'm assigning it the return value of the function 5. So so how this expression is going to run is that Python sees that you're trying to assign something to a variable called x, and then it evaluates whatever's on the right hand side. In this case, it's just calling the function, and then it replaces this with whatever the function returns, and then it assigns it to the variable. So yeah, so in this case, since the function 5 always returns the integer 5 directly, it's going to uh, it's going to always return 5, and so it's not a very useful function. Like, you know, we might as well have done, 5 equals 5 and said this as x equals 5. So functions are usually not very uh, useful if we want to return a constant. So let's have it return something more dynamic, and I'm pasting the function which I had deleted earlier, and this function is called add two things, and it takes two arguments called x and y, and then it adds them together and returns them. So yeah, you should be able to predict what happens if we yeah what happens if we call this function. So uh, yeah, in this example, you can see how we can how we can use this function to build a more complicated path. And so uh, in this expression, we're calling add two things with the arguments 10 and 20. And so Python evaluates it based on your definition. And in this case, the definition just says to return you know, the sum of those two things, which is exactly what's happening. And then we're assigning that to x and printing that out. So yeah, so is like, does this make sense to all of you so far? Okay, yeah. So that's a really good question. So one question I'm seeing in the chat is, how is a print different from a return? And let me demonstrate that. So let's define two functions called so this function is called print 5, and all it does is it prints 5. And the next function, let's call it return 5, and yeah, you guessed it right, it returns 5. And let's see how these two things are actually different. So so what happens when we call print 5? So if we call this function, it goes into this block and it prints 5. So this part is probably pretty clear to everyone. But what happens if we if we try to assign it to something. All right. So in this block of code, I'm assigning the return value of print5 to x, and then I'm printing out the value of x. So you can see that when we call print5, it actually prints out 5. And let's add like a little bit uh, of instrumentation to make things more clearer. So I added an extra couple of prints inside this function just so that we can see what's happening. And so now when we call this function called print5, we can see that it's printing out the statements we typed out here, which is starting function print5 and ending function print5. And it's also actually printing 5. But something which I want to point out is that so notice that this function doesn't have a return statement at all, like unlike this next function. So because this function has no return statement, it's just going to return none. So when we try to assign print5 to x, the what gets stored inside x is just none, because that's the default return value if you don't explicitly specify a return value. So now if we print out the value of x, we can see that the value of x is none. And so let's add similar debugging statements inside the function called return5 also to see how it behaves. And yeah, let's try calling return5 now. All right. So this is what happens when we call this function called return5. It prints this first line, which is starting function return5. Then it hits this next line, and once it hits this line and sees that we're actually trying to return something, it just returns that value and exits the function. So basically, because we already exited the function here, nothing under this actually, is actually run. So that's why we're not seeing this line in here. But uh, because we're returning something as opposed to the previous function where we didn't return anything, we can actually store whatever is returned inside a variable. And now if we see so when we run this function, we can see that the only thing that's getting printed out is this starting function return 5, and not 5 because we're never actually printing 5. We're storing 5 inside, like we're just sending 5 back to whoever called the function return 5. So in this case, it's going to just send 5 back here, and that 5 gets stored in X. And if we examine what's inside of X, we can see that it actually has 5 here, as opposed to none in the previous case. So does that explain? Does that clarify what the difference between print and return is? Okay. All right. So I'm gonna take that uh, as a yes. And I know this is technically like a lecture and not a worksheet type thing, but it's very useful to actually put these things in practice immediately after learning them. So I I'm gonna give everyone like maybe like 5 to 10 minutes to spin up a new collab document and basically do try this out. So let's say uh, so yeah, I want everyone to take 5 minutes to actually try to write out the code to do this. So we want to define a function called add 5, and this function takes only one argument, and it's supposed to return whatever that argument is plus 5. So yeah, so just implement it and test that it works, and you know comment done in the chat when you're done. Awesome. Yeah. So looks like a couple of you uh, have gotten it. So let's move forward. And so now let's look at how we can use these functions to build more complex things. So basically tie in the things you've already learned in the past. So I'm assuming so far you know what variables are, and you know how to assign things to variables. And I believe you know about lists. Correct me in the chat if you do not know about lists. And also, I think Rami's walked you through conditionals, specifically if else. So yeah, and now you know the basics of functions in addition to the previous things. And so you can use functions to basically tie everything together and limit the surface area of your code to a specific place. So let me be more concrete about that. So uh, yeah, let's define a function called yeah. This is building off the if else example you worked through previously, and let me make it like really really simple. So let's say anyone over 18. Okay, so uh, yeah, let's say that anyone over the age of 18 is eligible for the vaccine, and everyone else is not eligible for the vaccine. And this is a truth about the application we're writing, and it'll potentially be useful in other places. So uh, firstly, like, how would you actually check if someone's age is eligible for the vaccine? So I you do something like, if age is greater than 18, print. Yeah, so um, if I write if I write this conditional inside this block, age equals 20. If age is greater than 18, it's eligible, else it's not. And so since since age is 20 and it's obviously greater than 18, it's going to print eligible. And if I change this to something under 18, it's going to print not eligible. And this block of code works, and it does what we want, which is check if someone is eligible for the vaccine. But it's pretty useless beyond checking it once. Like, there's no easy way to actually reuse this in other places, and that's where functions come in. So if we take this block of code and So if I take this exact same code and put it inside a function, and as opposed to just at the top level like in the previous block, this now that this code is inside a function, uh, it makes it possible to reuse it in multiple places. So so if I set I can check multiple things. So I can check if 20 is eligible for the vaccine and it's printing eligible. And I can also check if 2 is eligible for the vaccine and it's printing not. And this is a good starting point, but since it's actually printing something and not returning something, it's hard to expand off of it. So you know so let's say that someone is uh, let's say that someone is eligible for the second dose if they had the first dose. No, actually, no, never mind. That's too complex. Let me make it simpler for now. So how do we actually use this? And the answer to that is by using returns instead of prints. And so I'm changing the print statements to returns so that we can compose this. And in this case, this function no longer prints anything, but we can compose that. And what I mean by that is we can use this in further if statements. So now that now that I've changed the print statement to a return, I can use this in further expressions. So now, for example, I've written a new code block which uses this function inside of an if conditional. So uh, so when I run this code block, it calls, it does the same thing. It calls this function and it checks if it's true B. Uh, Sorry, and I forgot to ask you if you already know what true T means. So let's take another step back. Okay, does I want you all to think about what uh, what is going to be inside X at the end of this expression. And so in Python, a lot of expressions can evaluate to true or false, and 10 greater than 18 evaluates to false. And so if instead of using it in an if statement like we had here, we had assigned it to a variable and printed it out, we'd see that it's false. And that same idea can be expanded to to the function which we had. So now we can use this function as a instead of age greater than 18. So let's create some new fake requirement. So let's say that uh, yeah, so I've just expanded the requirements which we previously defined. So originally we said that anyone over the age of 18 is eligible, but now we're adding a little bit more complexity to the problem and saying that anyone over the age of 18 and has no pre-existing conditions is eligible for the vaccine. So uh, how do we expand this function to support that? So so I'm adding a new argument called pre-existing conditions, and we use that in addition to the age to determine whether someone's eligible for the vaccine. So yeah, so expanding that function is pretty simple. We just have to, pretty much translate the English to Python and add and not pre-existing conditions to the definition of that. And yeah, let's try calling it now. So in this case, when I check if someone of the age of 20 and someone who has pre-existing conditions is eligible for the vaccine, it prints out false. And that's because we are checking, we're checking for this additional requirement. And if I run the same thing here, and I say that I say that they have no pre-existing conditions, then this function evaluates to true, which is what we expected. And that demonstrates like why we want functions in the first place, because the meaning of things in applications often change, like requirements evolve with time. And so we want to put all the code related to a specific requirement in one place, so that if the eligibility criteria for the vaccine changes, we only need to change one part of our code as opposed to like 10 places. So like suppose, there's some new guidelines which says that the new eligibility age is 15. In that case, we can just you know, change the definition of a function without changing the rest of the code. So it uh, limits the surface area of that basically. All right, and another thing before I give you like a quick exercise, uh, it can get like calling a function can get complicated if there are multiple arguments. Like what if the function had like 5 arguments? Like let's say uh, uh, let's say we needed like a third argument, which I cannot think of an example right now. But if we had a third argument, like we'd have to keep track of it, and reading the function call can get complicated. So another way to call the same function is we can use the name of the arguments here. So we can say age equals 20. So when we call the function like this, it's pretty similar to just calling it directly without the names of the arguments, but things are also clearer, because when someone reads this code like far away from the definition of that function, it's not clear what the false is for. So having explicitly specifying the argument here makes it clearer. And let's complicate this a little further. Let's say that we want to add a new criteria, which is now the pre-existing criteria exists for everyone, but now we have like a new eligibility age for men. And we want a new function called the all right. So we want to change the function to now take in age, gender, and pre-existing conditions. And I want all of you to try to implement this. Feel free to copy paste the previous block and expand on that. So basically, I want you to try to implement this this function with the expanded requirements. And an example of how we would use it is these are some examples of how we would call this function. We'd use a string to specify the gender. So I recommend all of you to to try to implement the new version of this function with our expanded requirements. And Yeah, let me know when you're done in the chat. Awesome. So, yeah, looks like a couple of you have uh, gotten this, and yeah, stop me if someone is stuck, but I'm gonna proceed for now. And yeah, I want to tell you, like, I guess some design considerations when it comes to functions. So we can see that, like, even with three arguments, like it sort of becomes hard to read the function outside of the definition. And so if you want to, like, do more complex things over time, so, like, for example, let's say we want a new requirement. uh, yeah, this is like a totally arbitrary requirement I just invented to, I guess, demonstrate how complexity can increase over time. So, suppose now there's a new requirement. Anyone who's traveled to China is not eligible, and so we want a fourth argument. So so now our function uh, needs to look like this. So yeah, as you can see, like, this gets kind of hard to manage over time, especially in terms of the previous examples. So now, suppose we're already using code which looks like this, which was the previous definition, and now this code would now break with the new requirement because there's a fourth argument. And so that's obviously not very scalable, because travel to China is a pretty uh, and like a rare thing, or something which most people will not have done, or will not even be thinking about. Like, so it makes no sense for us to have to specify it for every single call. So uh, what we can do is we can specify the default of an argument in the function definition itself. And yeah, I'm just implementing a very simple function to help debug. And this function basically just prints out all of the arguments. And let's try calling it with. So so as you can see here, because we didn't specify travel to China explicitly, it defaulted to the false value. And uh, if we need to specify that argument, we can do one of two things. We can just add a new argument, but it's considered bad practice because I will tell you why in a minute. Or we can do the same thing, which is specified by name here. So this behaves exactly the same as the previous case, except that it's clearer to read. But it becomes more useful when we have more optional requirements. So, for example, we can also make pre-existing conditions an optional argument. We could default it to false. And yes, and in this case, since we've specified the default value of pre-existing conditions also to false, if we don't specify it as an argument when we call the function, it's going to default to false. And the really cool thing about specifying it by name is that both of these are optional. So, for example, I can call the function with either one of those two or none of the two. So here I'm leaving out both of the optional arguments, and here I'm specifying only travel to China, and I'm leaving out the pre-existing conditions. Or or I can leave out the travel China and include only the pre-existing conditions. And finally, I can include both of the optional arguments in any order. So so because these are named arguments with defaults, so I've called them in a different order than the definition here. So in the definition of the function, we have pre-existing conditions first in the argument list before travel to China. But if we call them by name, then we have the additional benefit that the order doesn't matter. And that becomes like especially important when we have like 5 or 6 optional arguments, and that's something you'll see in a lot of libraries. So it's generally good practice to to have defaults and for all of your optional arguments, and have the default be sane, something which most people would use. And uh, yeah, and by doing that, there's a really cool benefit that any old code will not break. So now if I add a new requirement to the to this criteria, old code which doesn't specify it will still work. So our original our original call of just pre-existing conditions will still work even though we added a new requirement. And so it it allows you to build up this complexity in a manageable way. uh yeah, so I think that's uh enough for this lecture. And in the in the in the worksheet on Wednesday, we will actually try to use functions in I guess cooler and more connected ways, like use functions inside each other and mix functions and loops and stuff like that. So uh, probably like over the next few days, you could just play around with like function definitions and just generally like replacing blocks of your code with functions to make it easier to follow. And yeah, and we can like expand upon that on Wednesday. And yeah, so before we call it a day, does anyone have any more questions you want to ask in the chat? All right, so it looks like there are no questions. So let's give it a couple of minutes, and if there are no questions, I'll see you all on Wednesday. Okay, yeah, so it looks like there are no questions. So thanks everyone, and just wanted to remind you all to use the forums to actually, discuss things. And I will, oh, never mind. We do have a couple of questions. Okay, yeah, so the question is, it's a really good question, which is, so one of you is, yeah, yeah, so this is the question: unresolved reference to true while trying to return true or false. And the answer is that Python is case sensitive. So this works, and small true doesn't mean anything, just like any random variable which isn't defined. And there's only a few of these. Like there's these are called named constants, and these are called named constants, and the only three you'll need to be concerned about is true, false, and none. All right, yeah, so I hope that answers your question. And uh, one more thing I wanted to say was there are a lot of rules when it when it comes to function definitions. Like like um, the default value, for example. And uh, I think it's really important to know that you don't need to know all of them to be effective, and it's often more useful to learn as you go, as opposed to learning all the theoretical ways to define a function before writing any code. uh, so I'd uh, I'd encourage all of you to not worry about like the whole breadth of that topic, and just focus on like tackling any errors as you see them, and like learning the bare minimum amount of information to solve your problem. All right, thanks everyone, and I will expand on what I said about the functions rules on Wednesday. Have a good day, everyone.
Thank you very much, sir.